Welcome to the next episode of Navigating Carbon, your compass to carbon management. As always, I'm your host, Deb Ryan, and in this episode, I sat down with Katerina Yared to discuss all things geothermal energy. Katerina is an absolute expert on the topic, and we dive into the nuances of geothermal energy, both in terms of the subsurface, i.e., all the things that are going on underground, as well as some of the surface constraints and challenges in the space. If you enjoy our conversation, please make sure you like the podcast and make sure you subscribe to stay on top of all upcoming episodes. But for now, sit back and enjoy my conversation with Katerina. Hey, everybody, and welcome to our next episode of Navigating Carbon. Today, I'm joined by Katerina Yared. Katerina, how are you?
Doing good. How are you, Deb? Thanks for having
Good.
me.
Yeah, I'm excited to sit down and talk to you today because we're going to talk about a topic that we haven't tackled yet on the podcast, all things geothermal. Who better than to talk to than you? So, very excited. Um, so, as we dive in, for folks that maybe have heard about geothermal, but they're not quite sure how it works, let's start at the beginning. Like, when we talk about geothermal, what does that mean? How does it work? Like, what are we even talking about? Like,
Yeah, no, that's a great question. And actually, I think it's one of the questions that is missing currently in terms of tying it all together of what is geothermal all about, especially in the energy mix, right? So, geothermal is basically a continuous a source of heat that comes from the mantle. And there are different ways in which the mantle can be close or far away from the crust on which we're on top of. And that determines the capacity or the vicinity of the heat that we can tap into in many different ways, either to produce power or for simple district heating or, for heat pumps and things like that. So from big as power, as small as heat for your house, geothermal is there all the way. But yeah, that's what geothermal is.
and I think a lot of people might not really understand or recognize that it's there is that varying scale of what kind, like how much heat is generated from different geothermal projects and stuff. Do you have like, can you kind of explain the spectrum of that, or is there a way of describing that in terms of, if we're talking about very hot or a little bit hot or like what
Right.
does that mean?
Yes. No, that's a good question again. So the heat from like I said, it comes from the subsurface, right? And it also depends on what kind of geothermal reservoir you're talking about. Is it a conventional one? Is that one where we have almost like a convection system, right? Where the water or some kind of medium down below is transferring the heat through a porous media, just like we know oil and gas hydrocarbons in the subsurface are also in a reservoir like that. So you need to have a cap rock and other aspects similar to oil and gas as well. Or you go into igneous rock where the heat comes literally from the mantle through an igneous rock body, mostly sometimes, majority of the times, I would say, granite, granite in the subsurface. And we go tap that. So it varies there, and it varies in terms of degrees, according to how, again, the heat source is close or far away. We have the hotspots in Hawaii, right? For example, we have multiple hotspots on the Earth, but this one is another one where the heat comes straight out of the mantle, out into the crust, and we can tap close to that heat source. So it varies basically from, let's see, 100 degrees Celsius to about 450, where
Oh,
you're
wow.
closer to the geysers and all these people. Again, when they imagine geothermal, they think of this fumes of steam coming out. So that's not always the case, and but you can call that geothermal, and so many other things, right?
Yeah.
Yeah.
Yeah, I
Hmm.
think it's like you said, I think there's such a spectrum when we talk about this.
Yes.
It's not any one kind of heat source, it's lots of different ones. And so you started to indicate some of the places where we've seen some really successful geothermal projects and stuff. So Hawaii being one of them. Like, where else do we see effective deployment of geothermal around the world? Like,
Yeah. So I mean, the U.S. is currently the biggest power producer when it
Hmm.
comes to geothermal power producers, but then there is other countries, especially the ones around the Ring of Fire, around the Pacific Ocean, Indonesia, the Philippines. All of these take the advantage of being close to subduction zones, so where the tectonic plates meet and then create those magma plumes that come up to the surface and produce the steam, right? There is the steam was one of the first ways that geothermal got converted into power back in Lardarello, Italy, actually in
Yeah, there we
1904.
go.
Uh, somebody decided to put a pipe on top of steam coming out of the ground, basically,
Yeah, that's
to spin a
awesome.
turbine. Yeah,
That's really
that
cool.
yeah, so that those are the traditional ways of using geothermal, with just simply taking advantage of steam coming out of the ground and putting it into a system that would turn turbines that would create or generate power, right? But in general, those are the bigger ones. Turkey, another big country that produces geothermal for many years. Italy, yeah, and then
Very
the
cool.
countries around the Ring of Fire.
Which makes sense, yeah, from what you're saying. So, you're a petrophysicist by background and used to kind of identifying rock properties and things like that. Like, when we're looking at the different rock properties, like and looking for opportunities and things like that, like what what are we looking for when we're trying to figure out if something's going to be a good geothermal project?
Yeah, that's a good question too. And again, it depends in so many ways. And that's why I see geothermal very much relating to oil and gas in the sense that there is a conventional way of looking at it, say the Gulf of Mexico of geothermal, as well as the unconventional way of looking at geothermal. And over the years, recently, we have come to understand how we can use the properties that in the subsurface to be able to determine the capacity of geothermal power production, if at all, right? If that
That's cool.
that can be the end goal. But porosities are always important. You need to have flow of some sort. You need to understand if your reservoir is a conventional reservoir. If it is, then does the heat is the heat able to transfer to move so that we can continuously supply the heat from your
Hmm.
reservoir into your wellbore. The other piece is when you're looking at igneous rocks, the capacity of the minerals that compose that rock, how easy it is for those to transfer heat. So thermal conductivity and therefore heat flow is one piece that we hadn't have to worry about in oil and gas, right? But
Yeah.
uh, this one is one that is determined through the composition of the minerals, and so basically, XRD, so refraction data from your minerals is key in understanding the tie between that and your thermal conductivity, and therefore the reservoir capability to provide heat to your resource. And that's as a petrophysicist, that's what I was looking to find, and therefore finding similar properties according to the mineral composition and understanding how that then can transfer your heat, right?
So
Throughout
to
the
understand the mineral composition then, like are you taking rock samples, through core and other things to then get them in the lab? Is that how that is done?
Yeah, that is pretty much how you do it. And again, if you're dealing with a reservoir that is too hot to be able to get drilled or even getting a core out of it, you go to the outcrops and things like that and get
Ah, that
the
makes
rocks
sense.
from there. But
Yep.
yes, it is an important piece. The other important piece to the whole aspect of your reservoir is fractures and how fractures help you again deliver that heat to your well bore. And with the recent developments, like we saw in Utah and other places where they frack the rock to be able to create that pathway for fluids that they either pump down or have in place to go from an injection well to a producing well right next to it. So you're creating this loop, the convection loop yourself, but that has been a relatively recent
Okay.
aspect of geothermal energy harnessing. Mm-hmm.
So, so that I can understand that correctly. So, for some particular geothermal wells where there's more like traditional sandstone and porosity, you might be able to just use the water that's already in the subsurface. But for what you're talking about, it's surface water that's being injected to be heated. Is that, am I understanding that correctly?
Yeah, pretty much.
Yeah.
Yeah, you're fracking into a system and producing the fractures that you're creating, but as well you're giving the fluid within that system to carry that heat from your injection well into your producing well. Yeah,
Okay. Yeah,
yeah.
really interesting. So, are there other subsurface things that people need to take into consideration when they're thinking about geothermal and different development and stuff like that?
Well, I mean, I guess it is always important to understand the balance that you have to understand in your modeling, right? That you do beforehand, in terms of just like you're extracting hydrocarbons, you will extract heat out of your reservoir, and replenishing that might take a certain amount of time. And you can either balance it by just pumping less if it is a closed loop system, and maybe I should say that too. So there is open systems and closed loop systems. With closed loop systems, you're literally building a closed circuit of casing scenarios in the subsurface. And with open, you're building a fracture system that goes through the rock, and the two wells are just adjacent to each other, but not connected in any other way apart from the fracture system that you're building. So with that, you need to understand again the replenishment of that heat requires you to either slow down the flow or the amount of fracking when it comes to that open system, or in the closed loop system, whatever fluid you're using, and usually it's water, but now they're also looking at supercritical CO2, for example,
Oh, wow.
isobutanes or low boiling temperature fluid, right, to be able to create steam or some kind of thing that can then turn a turbine on the subsurface. Oh, sorry, on the surface. But yeah, so with these systems in place, you need to be able to balance that flow versus the heat that you're
The heat
extracting out of
transfer.
your reservoir.
Yeah.
Yeah,
No, it makes sense because if we, and so like again, then designing the surface systems in terms of what power is going to be generated or what steam is going to be generated, like that's going to have to, you can't almost like, over under design the system and make sure that that's all working together as well so that people
right.
don't rely on the power and then it's not there. So
Yeah, yeah.
it seems like from the original, use of steam in Italy, like you were talking about, to what you're even talking about now with some of the supercritical fluids and things like that. That there's a lot of focus and a lot of innovation in this space, which is something that is actually kind of exciting to me because I wasn't aware of all the supercritical fluids that were going into these systems as well. Is that rate of change in terms of some of the innovation? Is that something you're seeing a lot of right now in this space?
Yeah, in yes, definitely.
Yeah.
And like you said, it hasn't been taken into account in many ways in terms of investments, right? It geothermal always was a good to have, but not really. Why do we really need this, right? So with the recent advancement in trying to push a new energy technologies and clean energy technologies, geothermal kind of got this spotlight here recently with even oil and gas companies investing in them. And just that's to the purpose of being able to repurpose the oil and gas knowledge, for example, straight into geothermal generation of power, or even just the regular, district heating for that matter. But in particular, the recent investments are aimed to achieve high power generation from geothermal systems, which are tricky. You have to have certain things lined up. First of all, the reservoir, right? And understanding how you can drain that heat without depleting your reservoir in, say, 5 years or something like that.
Yeah.
Yeah, and that's a balance that I think is still to be tested in many ways. But recent advancements or recent technology trials, like the fracking of igneous rock, a granite pluton, right?
Yeah.
This is first of all, you have to drill it, and then stay within your isotherms, so the area where you can still drill and have casing and all that, and then frack. So be hot enough for that to be able to frack and create a system that produces power, but not so hot that you cannot put any iron down there, right?
Yeah, that's
But
a good
yeah,
point.
right.
Um,
So that's
yeah, because
about it for sure.
you're starting to talk about, like, talking about the subsurface challenges and stuff like that. Like, what about the surface kind of piece? You talked about like knowing where the reservoir is and things like that. Do we, we talk about a lot of things like hydrogen and stuff have to be quite proximate between the surface and where you're going to use
Yeah.
things, or where the generation is and stuff like that. How does that translate to geothermal in terms of then the surface considerations for project development?
Yeah, the surface development is a little bit more intricate in the sense that you need to have the right surface equipment to convert that heat into enough power or something that is transferable into a grid system, right? And so you need your power generation facilities and converters, for that matter, that you need to build either where you're fracking or where you're having your geothermal subsurface equipment, or something to transfer it, like a pipeline, right, into another power plant. And that's another thing that has, well, I guess it needed to be considered for it to make economic sense. But we saw a lot of big companies like Meta and Google trying really hard to get a piece of that pie, just because, for them in California, they get an extra brownie points if they go into a clean energy space, and therefore they're very much vested into finding these pathways to get to that target, right?
Well, and particularly for the technology companies and stuff, there's been so much written and talked about in terms of the increased power needs for everything digital and
Mhm.
AI and everything like that. So, like, on top of some of those, like, incentives, it's just there is increasing demand for electricity generally as well. So it's,
Yeah.
again, this and kind of conversation of all of the above, which is interesting. You briefly gave the California example, where there is incentives. Where do we see different sort of regulations and incentives and things like that, and how do we see that really sort of shaping the market, and demand for geothermal?
Yeah, no, that's for sure. That's policy is another big piece that was almost a barricade for many opportunities for geothermal, right? And for example, Texas in 2023, they just gave the heat ownership to the surface owners. Before that, nobody owned heat. There were mineral owners, surface owners, but the heat itself, it wasn't something that anybody could touch.
That's
Or
interesting. Yeah.
and that opened up a lot more leeway to many other projects that now in Texas are taking shape. And Utah and Nevada, just because they had geothermal there in their backyard for for many years, and developers were there for much longer for smaller projects, but still, they're much closer to a steam relationship there. Companies like Ormat, which is like the ExxonMobil of geothermal, they started off in Nevada, right? So they have big power plants there, and the heat there is a lot more capable to be turned into power generation, and that's where Ormat is quite heavily they own a lot of land and have a lot of power plants there, but in general, yes, policy was one that I think if a few more states would follow, I'm pretty sure as well, especially around the heat corridor around the Rockies area there, where heat gets is quite closer to the surface than to the east side of the U.S. Right,
Okay.
the west is a little bit more hotter, or closer to the surface hotter.
Yeah.
But people, even the government is looking into funding, supporting science and technology developments on the super hot side. So that's 400 degrees, or if not 450 degrees Celsius and above, right? So
Yeah.
they're aiming with technologies that are quite, they can come from a sci-fi movie, with and not even drilling just with the bits. They're actually drilling with microwaves or
Wow.
other technologies to be able to break rock deeper and further down without having that friction part, without having that other piece that can slow you down. So there is a lot of motivation to get to the core of the earth almost, right? And gather all that heat, because the super hot is what really makes a geothermal project viable and economically viable once you have that
Once you're down there
source,
to it.
right?
Yeah.
Yeah. Mm-hmm.
Which makes sense. And I think, like you said, you mentioned it earlier, but some of our traditional and existing technologies have temperature limits on them in terms of, which maybe a lot of people aren't aware of. And so seeing that investment and stuff so that it can be much more efficient in that system is really interesting. Are we seeing any other kind of like core areas of investment and innovation in this space to really kind of drive the development, or is it really just some of that super temperature or hot temperature stuff that you were talking about?
Well, I think a lot has to do also with like you said, the tying it to a grid. What does it take, right? Even though the geothermal heat might be somewhere, again, bringing it to the man or to the woman, right? That bridge step is something that needs to be thought about, and how to effectively or more without any energy loss, really, how to bring it to the people that need it in terms of power generation. The other piece that has been also long for quite a while is around us is the direct heat, in the sense that people can have a geothermal loop in their backyard and be able, with a heat pump, give heat and cooling to their homes. That's something that, for example, Europe has been investing quite heavily into, and getting that, just because it reduces one big chunk of the carbon emissions, right? It's a very low hanging fruit. It's easy to do. You just need to put a loop in your backyard, and a particular heat pump into your house, and you're done. And there are certain countries, but also states in the U.S. that are supporting it, and with a financial incentive. But yeah, that's something that people are more familiar with, maybe in certain areas than others, when it comes to
Yeah.
geothermal, right?
Well, it's really interesting, and as the conversation around the price of energy for for you and me in our homes and stuff like that, it's always and continuing to be a topic of conversation. And so looking to these newer technologies, we've a lot of us have got solar panels on our roof, and
Yeah.
maybe we'll start to have heat pumps in our backyards as well. So which is awesome. So Katerina, like, any final thoughts and stuff? It's been so great to have you on today.
Yeah, thank you. No, I mean, like I said, geothermal is something that needs education. People need to be aware of what its potentials are before they can even tackle it, right? And geothermal has been always sitting a little bit in the shadow of big oil and gas, but I think big oil and gas has a potential to transfer their knowledge that they gained over, even just thinking about unconventional development, the unconventional boom. It can help with the geothermal boom that we're all waiting to happen, right?
Yep. Which
Yeah,
would be
yeah,
great.
yeah.
I love it. Well, thank you so much. I know I've learned a lot today, which is always wonderful. It's been so great to have you on. So yeah, thanks so much for joining me today.
Thanks for having me, Deb. Thank you.